So we are reviewing for our first summative in PreCalc, and this is going to cover all of the linear review mess that we did the first week of class. And I know it seemed really fast, but to be fair, it was review. So our first section on our summative is going to cover all the coordinate geometry topics. So if you're looking in your packet, worksheets 1 and 3 are some good worksheets to look at, or if you go back to the posted slides or the answer keys that are on Google Classroom. Some concepts that you need to be able to do. So you need to be able to come up with the slope formula and also execute and calculate the slope between 2 points. So remember, our slope formula is y2 minus y1 over x2 minus x1. If my pen will work, I will write that down. There we go. y2 minus y1 over x2 minus x1. And you can reverse the order in which you subtract, but you must have the change in y over the change in x for slope. So for us, calculating slope, and I want the best answer you can give me. So y2 minus y1 over x2 minus x1 would be, let's see, that's negative 13 over negative 7, better known as positive 13 over 7. Of course, leave them as a reduced ratio, improper fraction if necessary, but watch your signs. You can find midpoint. First, you must give me the formula for midpoint. Remember, it's the average x and the average y. So you're going to add up your x's and divide by 2 to average them. And then same thing for the y's. So just to be clear, there are questions on your test where you have to give me the formula, and you will not be getting a good score on that section unless you can execute the formula, but also give me the formula. So finding the midpoint between these same 2 points, let's go ahead and use that same ordered pair set up there. 3 plus negative 4 over 2, and then 5 plus negative 8 over 2 again. So after a little simplification here, that'd be negative 1/2, right? Yeah, negative 1/2 and negative 3/2. Decimals are okay in that example because of the truncation. 0.5 is it ends. It's not going to go on forever, and you're not going to have to round and truncate. You have to give me a formula for slope. No, we already did slope. Distance, there we go, distance. So distance is the distance in the x's, so x2 minus x1 squared. Order doesn't really matter in this one, but it does have to be subtracted because it's distance. Plus, same thing for the y's, the distance in the vertical direction, squared. And then you add those together, square root them, that's the Pythagorean theorem component to it. So let's find distance of those same two ordered pairs up here. So for this part, I do take a little bit of liberties as far as shortcuts. So when I look at my x's, 3 to negative 4, that is a distance of 7 units. So like for me, I just write 7 squared. And then 5 to negative 8, that's a distance of 13 units. Yeah. There we go. Notice 7 and 13. 7 and 13 for slope as well, because those same, horizontal and vertical distances is how you find slope. So just kind of see the parallelisms there. And, oh boy, that's probably not anything pretty. Let's see, 49 plus 169 would be, oh, jeepers. I wish I could type. Oh, I'm going to type because I don't trust my brain right now. I would like a beautiful reduced answer if possible. Maybe you're lucky and it doesn't reduce, though. Square root of 218, which I don't think that does reduce at all. Let me do a little bit of typing on my calculator, though. Let's see if it's divisible by anything that's a perfect square. It helps if I type the right number. 218, hello. I'm trying 4, I'm trying 9. Looks like it is not divisible by anything that's a perfect square. So I'm going to leave it as the square root of 218. Okay, so a little bit more coordinate geo here. Can you graph lines? And can you graph lines in any form? So you have a couple options in this first example. It is in standard form, and you can rearrange it so it says y equals, or you can just find the x and y intercepts from standard form. And that would be a really great way to graph that line. So that's totally up to you. But remember, the x-intercept is where the y value is 0, and the y-intercept is where the x value is 0. So if we go up to the standard form line and I plug in or evaluate the function for y equals 0, this entire term is going to knock out because of the times 0. So 2x equals 10, which means x equals 5. And then similarly, if you do the same thing, except this time you're substituting in a 0 for the x, you get negative 5y equals 10, so y is negative 2 when you solve that. Then take it one step further because you actually have to graph this. I'd plot the x-intercept at 5, 0, boom, right there. And then y-intercept at negative 2, boom, right there. And then I'd so very carefully draw a line. Close. All right, this next one is kind of sort of in standard form. You have your choice. A lot of you don't like to do the x and y-intercept method. So if you don't like that method and you want to go old school and get y equals, all by itself, y by itself, you would add the 2 over. So we have add the x over 2/3. Oh boy, my pen is not working today. 2/3 y equals x plus 6, and then to undo a coefficient of 2/3, I would multiply everything by 3/2, which is kind of gross, but this first one is just going to be y equals 3/2 x plus 3/2 times 6, either on your calculator or in your brain, is a 9. So now that's in that quick graphing method, I could graph, up here, start up here at 9, and then your slope is up 3/2. So obviously you guys are going to graph beautifully and you're going to graph accurately. You have to decide on your technique and your method of approach. Can you determine if lines are parallel, perpendicular, or neither? So that is dependent on their slope relationship. So let's find the slope of A to B. So I'm just going to call that slope 1. 5 minus 6, using my formula that I already wrote down on my test, right? 5 minus 6 over 2 minus -4. Ooh, that's ugly. Is -1 over 6. And then slope for the second set of points, from C to D, is -9 minus -8 over 10 minus -3. Oh, what happened here? I kind of think this got changed on your review. I'm not sure. So I apologize if this is not the same as your review anymore. I feel like we changed this ordered pair. Anywho, this is a -1 over, right now is a 13. Okay, I am like 95% certain that we did something different on your review. So right now, they are neither. I'm not sure what your review says right now, and I don't have it handy, so I apologize. Right now it's this, and that would be a clear neither. However, pretty certain that we changed this ordered pair right here. To what? I don't know. I can't remember right now. But remember, if the slopes are the same, they are parallel, unless they happen to be the same line. But I'm here to tell you we didn't trick you like that on your first test. But in the future, you do have to be a little worried about that. If the slopes are perpendicular, that means they are opposite reciprocals. So opposite signs and reciprocal fractions. And then in this case, they're just nothing. So neither. I apologize. I'm pretty sure your problem on your review is a little different. Refer to the key. How's that? Alright, I can solve a multi-step equation. So this one, I'm trying to solve for C. This is just kind of a hot mess right now. A lot of things you could do. A lot of kids start by multiplying everything by a 4. I think that's a great idea, because no one really likes to work with fractions. Just be careful that when you multiply this, and then this, and this, everything by a 4, meaning every term. So this first term, the 4's cancel, and you still end up with 2c plus 11. But now this is a 36c, and then a minus 12. So you created a new equation, but at least there's no fractions. So subtract 2c, group the c's together. How about at the same time we group the constants together? And it will say in the instructions to leave your answer as improper reduced fractions, so keep that in mind. Alright, let's see, that's a 23 equals, oh boy, 34c, and then dividing by 34, leaving your answer as, oh my goodness, what is this doing? This is not my day, guys. Alright, 34. 23 over 34 is our final answer. If you're thinking it might reduce on your test, make sure you hit math enter enter. I will warn you, a lot of the questions, answers on your test reduce, and they're really funky fractions, so like they might not obviously reduce to you, so just always get in the habit of hitting math enter enter at the end of your problem to make sure you don't miss out on any of that. Okay, we will use the LCM or the LCD in a moment, but we already have this existing distribution, so I'm going to start by distributing the 1/7. So 1/7 times 2/3, you can just multiply across the numerators and denominators, or if you're really in a jam, you can just type that on your calculator and hit math enter enter to bring it back. 1/7 times 4 would be a 4/7. Alright, so now I'm going to add extra parentheses to the problem because now I'd like to knock out of all of my denominators. I don't want to have any. So 21, 7, and 3, the LCM for that would be a 21. And if I hit every single term, no matter what it is, by a 21, again, you can always type fraction multiplication on your calculator. 21 times 2 over 21, the 21s would cancel, by the way, but again, you can always type it. So 2x plus 21 times 4 7 would be 3 times 4, so 12. Same thing here, so 12x. All right, 3 and 21 would cancel to a 7. I don't know what that is. 19 times 7, 130 something. I don't trust my brain today, guys. 133. So we have an equation. It's not great, but at least there's no fractions. So we're going to bring all the x's to one side. And while we're doing that, let's bring the constants to the opposite side. Again, if my pen will work. Man. All right, here we go. Struggling, guys. 145 equals 10x. So this is a case where, since they want our answer in reduced improper fraction form, don't tell me it's like 14.5. That's a decimal. I don't like that answer. But if you type this and you hit math enter, oh boy, can't type either. 29 over 2 is a good answer. That's the one I'm looking for. And it must be reduced. You are going to be knocked down to a 4 if you don't reduce these. All right, next standard. Can you write equations? So first, you got to be able to come up with all three forms so you know what they mean. So slope-intercept form, that's the one everyone likes. That's y equals mx plus b. Point-slope form is our new friend that we're starting to like. Y minus y1 equals m times x minus x1. And then standard form is the one that nobody likes. It's this capital A, x plus by equals c. And just remember, for review's purposes, we need to know that a has to be positive. There's no fractions or decimals. And that's standard form. Yuck. All right. Remember, you have to know the formulas. That's part of your test. If I give you some instructions to write an equation in slope-intercept form, but we're not going to probably start there, I give you a clue about it being parallel to this line. So that's a clue about slope. Parallel lines have the same slope, so that means your slope is also 1/2. They give you an ordered pair. It is not the y-intercept, so what we're going to have to do is start in point-slope form. So y minus the y-coordinate would be y minus 8 equals m, so slope, which is 1/2, and then x minus the x-coordinate. So minus a -6 will do one of these things. And then, unfortunately, we're not quite done because I do want slope-intercept form. So let's distribute the 1/2. So we have y minus 8 equals 1/2 x plus 3. And then final step, add the 8 to both sides. So y equals 1/2 x plus 11. Very good. A little perseverance on our part. Can't quit till we get to the end of that. All right, the line perpendicular to this guy. So remember, slopes of perpendicular lines are opposite reciprocals. So the perpendicular slope to this line would be a -1/4. They give me the ordered pair 110, which is great, but it's not the y-intercept, so I'm going to have to use point-slope form again. And then just to be jerks, it says, oh, standard form is your final answer. So plugging everything into our equation, so y minus y1, so y minus 10 equals -1/4. Oops, I meant to make that blue. X minus x1, so x minus 1. So we have a lot of work to do on this question. For most of you, you distribute the -1/4 first. So y minus 10 equals -1/4 x plus 1/4. It would make sense to me to go ahead and add the x over, just judging what you guys have done, and then we're going to add the 10 over here. Ew, gross, never mind. Take that back. I would like to get rid of my fractions right now, because I don't want to think about adding fractions. I hate that. So what if we hit everything by a 4? So we have a 4y minus 40 equals -x plus 1. Okay, much better. Now I'm going to add the x over, and I'm going to add the 40 over. So, boom, look at that. We're already in standard form. X plus 4y equals 41. Awesome. Okay. Can you write the equation through 2 points? I don't know, can you? So unfortunately, they also want it in standard form. I don't even have slope, so I'm going to have to first find slope. So y2, ooh, that's a 4, minus y1 over x2 minus x1. Oh, gross, and it's a fraction. So this is 2 over negative 7. Yucky. Choose your favorite point. My favorite point today is this guy. So plugging into point slope form. Y minus the y-coordinate equals, and then it's the slope that we just calculated, right? So negative 2/7 x minus the x-coordinate. I'm going to show you a little trick. If you are not a fan of fractions like me, you can actually get rid of this fraction right here. I know the 7 is what I would have to multiply by to knock out this fraction. So if you were to multiply every term by a 7 right now, you actually would be done with fractions for the day for that problem. Here's the trick though, guys. This is all one term right here. So when you multiply 7 times negative 2/7, you are done with distributing the 7. This is going to become a negative 2. That will have to be distributed further, but as far as the 7, that would be the only place you distribute it because there's only 1, 2, 3 terms. So I don't really like to show everybody that technique at first because I think everyone's really freaked out. But this becomes a negative 2 x minus 1. Okay, now let's distribute the negative 2. So 7y minus 14 equals negative 2x plus 2. And then manipulating some terms around the equation, let's add the 2x and add the 14. So add the 2x over here, add the 14 over here. So 2x plus 7y equals 16. Kind of cheated with my showing my work here. That was dangerous of me. There we go, that's better. Standard form. Look at that. Beautiful. All right. Let's see if I do this right. I'm actually going to pause my video because I'm about to start class. Hopefully I splice this together properly and I pick up on this next question. Worst case scenario, I will make you 2 videos. Alright, so I'm back, assuming that I was able to splice these videos together properly. So we're looking at the creating equations section where it's really the same thing as the creating equations with 2 points, except it's a story problem. So here we have a game with a monthly plan where the customer pays a flat fee, monthly fee, and then so much per minute. So this particular customer, 125 minutes for $16, so that's the ordered pair 125, 16. And then similarly, where are we at? 90 minutes for $13.90. So using those 2 ordered pairs, where x is our number of minutes and y is our total charge, find the cost per minute. So this is a really fancy way of saying find slope. So if I go find slope, I get, let's see, $13.90. Oh, pen's still not working. All right, $13.90 minus 16 over 90 minus 125. So this does come out, I believe, to a positive slope, yeah, and it looks like 6 cents. So find the equation of the line. It'd be cool if I had the y-intercept, but I do not. So I'm going to have to use my favorite point, which, I don't know, how about this point right here? So plugging that into point slope form, and I have to use, remember this is the x and then c. If you started with y, you just got to change it out for c at the end. So c minus c1, which is 16, equals the slope, which is 0.06, and then x minus x1, which is 125. Okay, so you've got to do a little bit of work here. They want you to get it in c equals form. So distribute the 0.06 and then add the 16. So you do that in 2 steps, of course, but I'm going to skip ahead a little bit, and I get 0.06x plus 8.5. So monthly fee of $8.50 and then 6 cents per minute. Now we're going to use our model to predict the cost if we use 225 minutes. So we're going to plug 225 in for x into this equation right here. And rounding to the nearest, oh, you know what, it looks like it's a whole number here. So $22. All right, moving along. Linear regression is all on the calculator. So I think I already entered this data into my calculator, but what you have to be careful is x equals 0 corresponds to 1985. Remember, we don't like calendar years to be like the x variable. So pretend like time starts in 1985. careful, 1990 would be 5 years later. This is not counting by ones. And then this would be 10 years later. And then this would be 15 years later. That is not legible. I apologize. So this is 0, 5, 10, and 15. So entering that data into my calculator, I'm going to go into list 1 and list 2. I think I already did it actually. Please pause the video if you didn't get your data entered yet and you're practicing this step. So list 1, list 2. Remember, this is all about muscle memory and keystrokes. So if I need to come up with the linear regression equation, you go to stat. We edit to enter the data, remember, but this time to calculate, we're going to calc. I'm going to choose the fourth one, which is linear regression. My data is in list 1, list 2. There's no frequency list. And then we should always get in the habit of storing our regression equation in y1. So go to varies. And then over here to y varies. It is a function called y1. Boom. All right. So calculating that, it'll give you ax plus b form, and then r equals is the correlation coefficient. So on our paper, we're going to be writing down y equals, this comes out horribly beautiful. You're going to make sure you round to the nearest thousandth on your test. That does not come out beautiful. So 300. And then the r that we're going to jot down is this guy here. So I'm sure the directions are very clear on your summative. It might not be here, but that's okay. Formula was, let's see, 85x plus 300. Remember, this model is measuring time from 1985 on. What is the correlation coefficient? That was what, 0.998 when you round to the thousandth? And then is this a good model? Yeah, anything, rule of thumb, anything above 90%, 0.9, would be a good model. And then using your model to estimate the cost in 2019. So remember, years since 1985. So that's 15 years plus 19 years. What did I just say? 15 plus 19 would be, oh my gosh, 34? Should be able to do that, right? So x equals 34. Since this is such a beautiful equation, you could just manually plug in the 34. But what I would rather you guys get in the habit of doing is going back to your calculator and using your table feature. Now remember, we set up our table to be in ask mode for the independent variable. So when I go here and I say I want the, I already forgot what it was it 34? Yeah, the 34th year, and I go and I look at the number, it is $3,190. So that is what I write down. Okay, so there are lots and lots of examples that you can find. Remember, all of your homework assignments, even though you may have turned them in for your homework check, everything is on Google Classroom, and you can see pictures of things, and you can go through extra practice problems that were on your notes. Maybe we skipped a couple. There's no harm in redoing problems that you've already finished because, you know, no one has that kind of a weird memory where you memorize every answer. Keep this in mind. I did go back and look at that one weird question with, I messed up with slope. You know what I messed up, though? I told Mrs. Hofbauer how to fix it, and I told her wrong still. So it is totally my bad, guys. What problem was it? It was, yeah, this one. So I totally screwed up, right? What I wanted this problem to do, let's see, I needed to change this number to something totally different. I don't even know what I want to change it to at this point. So I apologize, Mrs. Hofbauer's class. Your teacher rules. Mrs. Abruzzo drools. I'm sorry. And we needed to fix that to something else. We were trying to illustrate to you guys that when slopes are perpendicular, when lines are perpendicular, that their slopes are opposite reciprocals. So we're trying to, we want to go through some examples of things that are opposite reciprocals. What I don't want you to think about, this is the common mistake in geo. Sometimes we get this, and a kid says, oh, these are perpendicular. No, not true. They are not perpendicular because they don't have the opposite, they aren't reciprocals of each other. Similarly, sometimes kids think these are perpendicular. Well, that's not true because while they are reciprocals, they are not opposite signs. So just keep that in mind when you hit your question on your test. What's parallel, what's perpendicular, and when is it considered neither? And you have to be able to explain that as well. All right, I digress. I apologize for that mistake. It won't be my last. Fingers crossed.